Okay, I hope that first part wasn't out of focus. I don't know if I had it on manual focus. Anyway, here's the way this works. All right, let me show you. First of all, these are just terminals that can be wired. These are just terminals that can be wired anyway. You want to wire them, it doesn't really matter. This is a large industrial style varistor or whatever. Well, the way it works is you've got a voltage that would come in, and let's just say for sake of argument it's going to be 12 volts, and I can show you this on the board here. And then we have ground, so it's 12 and 0. And then wherever we put this band, it's going to measure the voltage. Potentiometer, measure voltage. Potentio is voltage, meters measure. Measure voltage. Remember, language is important, guys, because the word tells you what it does. Okay? A battery is called a battery because the word battery means repeated over and over and over again, like artillery battery. For those of you guys in the southern states who are Civil War recreators and go out there with your artillery battery and your field piece out there, it's called a battery because it's the same thing repeated over and over and over and over and over again, which is why it's called assault and battery, because you do it again. Okay, it's bad enough that you do it. I don't recommend you do it again. Okay. At any rate, so what happens is this coil of wire has a resistance, and it drops voltage because anytime current flows through a resistor, voltage drops. And we've talked about there's a voltage drop video out there and stuff like this. I'm trying to kind of tie all these things together for you. So let's assume it starts at 12 here, and this is all uniform and very well built, and it's German, so it must be. And we start at 12, we end up at 0. Okay, well what that means is it's going to start at 12 and go la 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 boom to 0 because voltage drops, and it's going to drop over the entire length of this wire, which yes is insulated even though it doesn't look like it. So starts at 12, blah, 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 down to 0. All right. Well, what that means then is that as the voltage drops, it can be measured, potentiometer, it can be measured at any point in that process. Okay. Hence the reason that the symbol looks like this, with a little line on it, because here's the little line. This band right here is the wiper. Now we can move this back and forth to pull off a particular voltage. Now in this particular case, this isn't just for measuring voltage. This actually has a current capacity because of its size. Okay, so because of the size of this, it's possible to actually tap a voltage that can be used to do things. Now that's not typical, especially in the smaller stuff like, come on, like, where did it go? Like that one right there. Okay, see that right there? Okay. That's a small one. You're not going to run a motor off of that potentiometer, but you could technically run a motor off of this because it's big. Okay, but the same idea works. So it starts here, drops to 0, and anywhere we set this band, we're going to get a measured voltage. All right, and this is a really good big example. Let me just point out too that making the transition from a drawing to the actual machine is hard. It's not easy. It's hard. All right? It's one of the hardest things my students have to do. Next week I'll be up in Pennsylvania, Amish country for 2 weeks. Okay, lots of really nice, really sharp guys up there, and it doesn't matter where I go. Everybody struggles with going from black and white drawings to mechanical things. Okay, it's just normal. All right, you have to practice. For those of you who have my book, let me make a recommendation. By the way. Go to the drugstore on the way home, or Kmart or Walmart or whatever you have, whatever mart you have in your area, and get a package of index cards. Okay, it seems crazy, but like a first grade kindergarten thing to do. But if you've got my book, take the book in the back. Hopefully you've seen them. There's schematic symbols back there, like 7 pages of them. And make flashcards. Draw a really good dark picture of what it is on the front, and then flip it over and pencil or something so you can't read through it, because we're all going to cheat, whatever. And then so write coil and then draw a coil. Well, the cool thing about this is that as you go through this, you can start practicing at lunch. Just leave them on top of your box. Put whatever, put them in your top box or something, and pull them out. Just go flip, 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 and the ones that you keep getting right, the more you get them right, put them in the back of the stack, and then go through the ones, and when you see whatever, start over, and learn them. Just learn them. It's like learning a new language. It's like learning new words. It's a good way to go. It also works because if you do get the schematic out and you do start getting, gung-ho into this whole thing, then you can make notes on the cards and say, oh, well, this was on a Kenworth, or this was on a Cummins, or this was on a CAD, or this was on a Komatsu, or this was on a Kobelco, or this was on a John Deere, or this was on a industrial Q-tip manufacturing plant, or an Aztec cement asphalt plant, or whatever the heck it is you work on. For if you're a student, duh. All right. Okay. All right. I'm going to start with the potentiometer, because quite frankly, the language is just easier to understand. It's easier to understand if you've been measuring voltage drop and blah, 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 blah. Okay? Again, people say, well, why do you repeat things? Well, because you remember them, because when you get bored, when you get bored of what I'm saying, congratulations, you're learning. That's important. Potentio here means voltage, and this means to measure. So we're measuring voltage at terminal 2, okay? So remember, terminal 2, on any schematic you look at, it doesn't matter. Terminal 2 is always going to be the signal wire, all right? Now, if you notice, what I've got is I've got the meter grounded, which is what you do. I've got this one grounded up here too, but that's coming later. And I'm reading full system voltage. Well, the reason I'm reading full system voltage is because the wiper inside is all the way over here on the 14 volt coil or piece of ceramic or whatever. So in other words, this is 14, so this is 14. Okay, so the wiper's all the way over here. This is 14. That's 14. Okay. Now, here's what's happening. I'm measuring at terminal 2, which is the signal wire, and as I adjust the potentiometer, notice what happens. Okay? Now, I want you to watch too to see if this meter glitches. This is one of the first times I've actually used this meter, and it works on 6s. So around the 6 volt range, we may get a meter glitch, and I'll explain that again for those of you guys who want to test these sensors and throttle position sensors. Let's watch what happens around 6. Boom. Yep, you see it glitch? Okay, you see it kind of burp there? Okay, that burp. Now watch again. See if I can slow motion it. Whoop, whoop, glip. Notice it's a little bit above 6 when it happens, going up. It's a little bit below 6 when it goes down. Okay. Remember, that's because the meter is on auto range and it's changing ranges. This is not defective. This potentiometer or throttle position sensor is not defective, okay? So what do? Well, you raise it all the way up to the highest possible number, which would be the other way. This is the only time that I ever tell anybody to touch that range button right there. Because what it will do is it will lock the meter on the 60 volt range. Notice that the little auto light went away, or the auto whatever. Now watch what happens, the glitch is gone. And this works on ohms, it works on volts, it works anywhere at all. But for sensors and the like, you need to be very careful because you don't want to get really excited about changing a throttle position sensor when the throttle position sensor is not defective because you misread the meter. And now watch what happens. As we adjust the throttle, adjust the position, this is the measured amount of voltage going back to the computer or the whatever. And notice now the glitch is gone. Yay! Yay! Okay, the glitch is gone because the meter is not jumping ranges now, and I can see the full sweep of the potentiometer. Now we're all the way down at the 0 volt range, the 0 volt piece, part, whatever, because that's ground. Because this is now touching ground, and if you remember, 0 volts means you're touching ground. So we're touching ground. Go all the way back the other way, boom, full system voltage, go all the way back the other way, boom, okay? Now, this particular potentiometer does not have a mark on it, but some do to tell you, so let's see if we can figure out the half part. 14.8 would be 7.4. So let me go to 7.4. Yeah. I'll take it. Okay, now, well, if I turn the circuit off and go to ohms, I've got 2.5 thousand. Well, guess what? This is 5K. So here I am. I'm measuring half of the voltage. Let me go back to volts. Turn the circuit back on. I'm measuring. Did I touch it? What did I do? I must have touched it. Ah. Okay, let me do this again. Okay, so we go up. Oh, wrong way. Ooh. Go back to auto range. 2 seconds goes to auto range. Go back up to 7.4. Anytime if you're on the manual range, just hold the range button for 2 to 3 seconds, and it goes back to auto. That's true of every meter. Okay. Ooh, nailed that one. Okay, let me not touch anything here. If I turn this off, this is a 5K or 5,000 ohm, and sure enough, 2.5K or 2,500. So I'm actually measuring half of the resistance and half of the voltage, and that's how this works. Okay, so to center this potentiometer, and be careful, be very careful before you install sensors on big pieces of equipment and booms and conveyors and tracks and all these things. Read the instructions, because it will say, make sure the track is at this position, or make sure the bucket is at this position, or make sure this conveyor is, like, centered or whatever. And then center the potentiometer and then adjust it so that it has the 3 prongs pointing straight up or straight down or straight back or straight forwards or whatever, and then clamp it down, because if you don't, hey, who did that? You don't want that to happen. That's bad. Okay, so really there's nothing else to tell you about a potentiometer except to look for any type of symbol on the schematic that has 3 separate wires leaving. If you wire these 2 together, it's a rheostat. So that doesn't count. Okay? But if you see 3 separate wires, potentiometer. Okay? All right. Well, that's pretty much that. Okay? This coil by itself is 14.8 or 15 ohms, and if I short across from the center, I get a changing resistance. All right. Well, Rheo means flow. Right here, Rheo means flow. Stat means static. So if I adjust the rheostat, okay, and if I adjust the rheostat to a given position, then this new resistance is going to change the flow through the motor. Excuse me. And what I can do in this case is I can actually read the voltage drop. So let me bring the other meter back in here. Bring this in here. So this is going to be, the 485 is going to be the rheostat, and this 597, which as you can see is pretty beat up. All right, now the motor should start running as soon as I plug it in here. When I turn this on, and what you're going to see is a voltage drop across the motor and a voltage drop across the rheostat. All right, and when we do that, it's going to add up to full system voltage. So let's see if this works. Okay, so here we've got 4. Wow, that's pretty doggone good. It's almost exactly 4, and 10.7 makes almost exactly 14.7, and we were running at about 14.7 if you remember from the previous experiment. Okay, now 2 things are going to happen. And I want you to be very careful in your analysis of what's happening, because both things happen at the same time. As the voltage across this drops, that uses up energy, and this is getting damn hot. Okay? That energy is this. This is how much energy this is using. So this is currently using 4 volts. This voltage drop is what's controlling amperage, because this resistance plus this resistance, two resistors in series, will add, ow, that soldering iron's hot, ow, that's, I'm okay. Two resistors in series will increase resistance. Notice that the motor's spinning faster, so it's using more energy. Look over here. Now the motor's spinning really fast, so it's using more energy. Well, doesn't that make sense? I mean, doesn't it make sense that if the motor's going faster, we're giving it more gas or voltage? Okay, so that's all we're doing. That's all a rheostat does. And let's see if I can do this better so you can see it better. When you get over here, it doesn't change because it's the same voltage. You get over here, it's, oh, ow! That's what makes at-home learning so much fun. Okay? Now notice that the rheostat is dropping, come on, virtually no voltage, but it is 2/10. If we add 14.5 to 2/10, we get 14.7, and the total voltage is 14.7, so voltage drops must add up to system voltage. Okay? So let's see if I can figure out this amp flow thing. I'll just pull that out, and I'll pull this out, and then what I'll do is I'll look, wait a minute, which one was that? Is that this one? Yeah, that was this one. Okay. Fun video, huh? Lots of crap going on. Burning myself and cutting myself and all that kind of, I don't want to do that, that's bad. All right, so here's what I'm going to do. I'm going to clip this under here, first of all. That's easy. And then I'm going to put, yeah, it auto off, right, gotcha, okay. Then I'm going to put this one here. I'm going to put it here, because it's easy. We should be reading about 0 volts, because we're just reading the voltage now across. So what I'm going to do is I'm going to pull this out. I'm going to turn this off. Now what did I say? I said, see if you guys can follow me here. This had 4 volt drop. This had, 10 volt drop. Well, the ratio is 4 to 10 or 2 to 5. That's my alarm. Okay, here's the deal. 2 to 5, here's what I figured. If this is 15 ohms and dropping 4 volts, then this has to be 2.5 times greater. So 2.5 times 15 is 15, 30, and half is 15, so it's 45, so total 60 ohms. 15 over 60 is a quarter. So it's about 0.25 amps. So if I'm lucky, I will move the black lead, not. I'll move the red lead here. And if I move this to amps, I get 0.25. And I'm going to be, listen guys, I did not do this before. I have balls when it comes to this concept because I know it. I know Ohm's Law. I know basic math. I know that the voltage drops have to be proportional to resistance. There's one current flow. The current flow is 0.264 amps. If you want to figure this out, you do it this way. You have your total source voltage of 14.7. You've got 15 ohms. You've got 0.25 amps. Volts over ohms equals amps. Or volts equals amps times ohms. A quarter of 60 is 15. Well, this is the important thing. You cannot measure the amperage of the motor. Disregard, wrong. You cannot measure the resistance of a motor. You can only measure its effective resistance, because watch what happens. When I slow this motor down, here's a dragging starter, and here's the amp flow through your battery cables. Let's say this is your starter, and let's say that's 250 amps, okay? Now watch. As I slow the starter down, boom, your cables blow up. Why? Because when a motor slows down, it has less effective resistance. Okay, that's the end of the demo here. I gotta go. I got lunch with somebody. But when I come back from lunch, I'll edit this and put it back out there, and hopefully this will be done. Now, this was a good one. I like this one. This was a good one. Wasn't it more exciting? And did I really sound like Obama? I hope not. Okay, let me shut this. Oh, that's right. Amp meter's a jumper wire. Remember, amp meter's a jumper wire. Be careful.